Dear students, let's continue from our subject. Now we are going to see the concept of normal distribution. A random variable x is said to follow normal distribution with parameter mean and variance if it has the PDF fx is equal to this formula where we are having minus infinite is less than x and a plus infinite. So here we will start in this formula that we are having pi and standard deviation and the error and the mean and x. So if we have a function like this, and if we have a random variable which satisfy this condition, it means that we are having a normal distribution. So here minus infinite must be less or equal, must be less than mean and the mean less than infinite, and the variance must be greater than 0. So the normal distribution will be denoted by the big X where when we are having n and mean and the variance. So it means that we have a normal distribution which will be defined in the term of x, n, mean and variance. So here we indicate x, or we will say that x follows normal distribution if it has the following properties. Which properties? Two properties. The first one is limit going from x t minus infinite, where we are having fx is equal to 0. This also will be equal to limit fx when x is tending to plus infinite. It means that when we go to the minus infinite or we are going to the plus infinite, both of them we tend to be equal to 0. So it will be the same. The second property is that normal PDF will be called symmetric about mean. That is, f mean minus x will be equal to f mean plus x, because here in the positive part is equal to the negative part. So that is why it is symmetric, because when we are in the negative part, the result will be the same as in the positive part. It will be the same. So that is called symmetric. So the symmetry for normal distribution is shown using following diagram. You can have the symmetry of this distribution using the diagram, because when you are watching the diagram it will be very easy to interpret them. So here I am having minus infinite plus infinite, then x is equal to mean. It will be equal to mean when we are in the half of the diagram. This is the fx where fx is equal to 0 here. So this part, it is the part of the negative negativity, and we are in the part of positivity. So the third one is the maximum value of PDF occurs at x is equal to mean. The maximum value of this our function will be occurring here in the half, where x is equal to mean. So the mean and the mode also will be equal for normal variate. If we are having a normal variate or normal distribution, the value of mean and the mode will be equal, the same. If the random variable x, n, mean and variance, then we are going to have another variable which is called z, which is going to be equal to x minus mean out of standard deviation, where we are having n, when we are having n pertaining between 0 and 1. So that is, if x, what is the meaning of this? The meaning of this is this. It means that if x is a normal variate, then x minus u out of standard deviation will be called a normal variate, which is z, and a normal variate with mean as 0, mean will be equal to 0, and variance to 1. Yeah. Variance is, this is a mean, this is variance. So now z will be called a standard normal variate. So z is called, its name is standard normal variate. So the area under standard normal variate curve is 1. The area under normal curve is 1. The area under here. Here, it means that we are having 1, here minus 1 tending to minus infinite, here tending to plus infinite. So, for solving many problem using normal distribution, we make use of standard normal variate, and the predefined probability table is available for standard normal variate. Yeah, we can solve so many problems using a normal distribution. But we will have to have two things. The first one is standard normal variate, which is a z, and a table, probability table, which must be a variable, because it has so many values. We will check the values through the table to know what is the results. So let's have an example. Let x be a normal variate such that x and n, we are having 50 and 9. So 50, the 50 is, this 50 will be what? Will be according to the formula we are having here. We are having 0 and 1. So here we are having, mean, it is a 50, and the variance 9, this one. So we have to compute the probability that the x follows normal distribution when x is less or equal to 56. So what is the solution? It is given that the mean is 50 and the standard deviation is 9. That means that the mean is 50, the standard deviation is 9. So variance, this is variance. So the standard deviation will be 3, because the standard deviation is equal to root of variance. As variance is 9, so standard deviation will be equal to the root of 9, it is 3. So we have to compute px is less or equal to 56. This can be understood with the help of the following diagram. So with the shaded area indicates the required probability of x less or equal to 56. We are having x is equal to 50. This is x from here, tending from minus infinite to plus infinite. So x is equal to, is less or equal to 56, means that it is going from minus infinite till 56 here. 56 is here, and the mean is here around 50 here. So, and we are having z by the formula is equal to x minus mean out of the standard deviation. So so z will be equal to what? X is 56, this one, minus mean which is 50, divided by standard deviation, which is 3. We are going to have a 2. So if we are having 2, it means that our requirement is P. We are going to calculate the probability when we are having P z, where the probability where z is less or equal to 2. So we can refer to the standard normal distribution, can find its value, this probability, you can find the value of this by going through normal the distribution table. This one is a cumulative table, so we are going to get this value. How did we get this value? Let's check. So let's check where we are having z is equal to 2. Z equal to 2, it means that we have to check here. We are having z. We can check from here or here. Z. Here it is z is equal to 0, and here 0, same to 0. Let's continue down where it is 2. So z is equal to 2. So we will search from the first column. So it is here. This is the value. We find that when z is equal to 2, the probability will be equal to 0.97725 here. So let's go up. So we find that the value when the probability x less or equal to 56 is 0.97725. So we can have the second example. The time required to load a ocean going vessel. This is a ship or a boat, a big boat. So what is the time will be required to load the vessel? It is x, and this is distributed as n 12 and 4. This is mean 12, and we are having the standard deviation of 4. It means the variance will be equal to 2. So compute the probability that the vessel will be loaded in less than 10 hours, more than 12 hours, or it will be loaded between 10 and 12. First we start from, we're going to calculate the value of z. The value of z will be equal to x. Here we're having 12 and 4. The mean is 12 and the standard deviation is 4. So we are having to have a z is equal to x minus mean 12 divided by 2, which is the root of 4. So in the range of 0 and 1. So the first question, we have to compute the probability that the vessel will be loaded in less than 10 hours. In less than 10 hours, it means that when x, the probability when x is less or equal to 10, which means that z will be equal to x minus 12 divided by 2, which will be equal to minus 1. If I put a minus 1, it means that the standard normal curve will be how? The standard normal curve will be, here we are having minus 1. Minus 1, here we are having 0, mean is here 0. As we are having 0 here, it means that the minus 1 will be almost here, minus z will be equal to minus 1. So z, it is this zone from here till the beginning. So we have to calculate the value in this zone when the x is less or equal to 10. So we know that the normal distribution is symmetric. It means that if it is symmetric, it means the minus 1 here, z is equal to minus 1 is equal to z is equal to 1. So here, when z is equal to 1, it is almost here, this. So this part is equal to this one. This we are in positivity, here in negativity. So what we are going to have, we are going to have the same part, which is almost like the same here. It is the same. So as we have a symmetric, so this part and this one will be equal. So when they are equal, this can help us find the one part. If we are having this part, we can calculate this one, no problem. So it means that P, as it is symmetric, it means that Px less or equal to T, this will be equal to 1 minus P x greater or equal to T. It means that if I am having x as the mean is equal to 0, greater or equal will be in both parts. So this will be equal to the opposite of it. So the opposite of this it will be this one. But equal will not be there. But we have the mean when we are at the half, and the mean equal to 0. That is why the equal sign will come. So this will be equal to minus this is 100%. 1 is 100%. Minus this the opposite side of this. So you will find this one. So if we do like this, we are going to have Px less or equal to T here. It is this part here. So using cumulative standard normal table, we will get Pz less or equal to minus 1. Minus 1 is what we got here. So z less or equal to minus 1, which is this one here, this part, will be equal to 1 minus Pz greater or equal to 1, which is this one. So it means this part, the part here, will be equal to this part. But we have to remove, we have to do what? We have to take 1, which is the maximum, subtracting the opposite side. So we will find what we are looking for. So if I have 1 minus Pz greater or equal to 1, we are going to see in the standard normal table and check. So I go here to the cumulative normal distribution. I go where x is greater or equal to 1. It is in this part here. So we are having 1 here, greater or equal to 1, so 1 is included. So I start from the first column here, when we are having a mean equal to 0 here, having a mean equal to 0. So I check here, I see that it is 0, 0, 8, 4, 1, 34. So I go up and check. I find this one, so it is okay. Then I take 1 minus this, I find 0, 1, 5, 0.158666. The second problem is about more than 12 hours. It means that the vessel will be loaded in more than 12 hours. So you're having a Px greater or equal to 12. So we're going to have a z is equal to 12 minus 12. This is it. This is x. This is the mean. Then this is it. The variance. So it will be equal to 0. So we need to compute the probability when z is greater or equal to 0. So the curve will be in the half. It means when mean is equal to 0. So this is in half. So we don't need to refer to the normal standard normal distribution. By using our eyes, we can see that that the probability is half, because we are here in the half of the graph here. So it will be 1 out of 2 or 0.5. So the probability that the vessel will be rolled in more than 12 hours is 0.5. The third question is the vessel. What is the probability that the vessel will be rolled between 10 and 12 hours? So we have to compute the probability that that 10 is less or equal to x and x is less or equal to 12. So here we are going to use the standard normal variety. So we are going to see that -1 is less or equal to z, and z less or equal to 0. We found when we found in the first question where we were computing the probability that the vessel will be loaded in 10 hours, we found -1. Here in the second question we found that if it is to compute the probability that the vessel will be loaded in more than 12 hours, it will be 0. So z must be between -1 and 0. So the curve will be like this. It means that we are having minus infinite, plus infinite. I am having -1 here, coming from here to here, and the 0 from here to plus infinite. So in between them, we are going to have, when we are having minus, probability that it will be between -1, it means in between 24 hours and the 10 hours and the 12 hours. Sorry. Okay, so now using the symmetric conductor of normal distribution, we say that the required probability will be area from -8 to infinity to 0, -infinity to 0. Here we take this part. We are going to subtract area from -infinite to -1 here. So we take this zone, this area, minus this one. So we remain with this one. This. So what will happen? We will find that from minus infinite to 0, minus infinite to 0 is equal to half, as you saw in the previous problem. And area from minus infinite to -1, from here to here, so that is this value. We check in the previous example, so we find that it is the probability is 34134. This one. So the probability is almost it is 30. It is 30. It is about 1.3 of the full probability. So we can have also another example 3. Let's check the example 3. We are going to see red time demand x for an item has a distribution in 25, 9. Here we are having a mean and the variance of 9. Compute the probability, the value of red time that will be exceeded only 5% of the red time. So we are having a red time, but the red time has to be exceeded by 5% of the time. So the time will be exceeded. So how to calculate this? So here we need to find some value x0 such that px is greater than x0. So the normal time is x0, so x is additional time to x0. So to find the additional time, you have to have x minus x0. So x minus x0, this is an additional time. It is it must be equal to 5% minus 0.05. So here we are having the probability that x is greater than x0 will be equal to pz greater than x0 minus the mean out of the standard deviation here. So what we are having this will be equal to the opposite. So this one will be equal to 1, which is 100% minus the probability, this one. So because the opposite of this will give this one, then this will be equal to 0.05. So if I put a pz less than x0 minus 25 out of 3, which is the opposite of this one, so it will be this one. It will take 1 minus this, we will find this one, this. So now we are going to search the cumulative standard normal table for value 0.95. So we are going to find it. We are going to find it in a cumulative standard table when we are having z is equal to 0.95. We are going to find it. We are going to find it at 164. Let's check how to find it. So we are going to check. We are having z is equal to 0.95. 0.95 we will check here. We are having 0.94, 0.9460.3, 0.9473, 0.9484.8.25, and 0.949. This is the approximate value. It is an approximation near to 0.95 here. Here it is okay, because when you go here, this value is greater than 0.95, so it is not the same. So there are an approximation is here. So when we check, we are going to find why it is at 1.60, but at which column? 4. In the column 4 here, this one. So we want how to find it? We take 1.6 plus 0.04. If we add them, we will find that it is we are going to have 161.64 here. So 0.949.50 is found at 164. So it is okay. So it is found here. So we will see that x0 will be equal to 29.92. It means that we are going to find the value of x0. The value of x0 will be equal to 1.64 multiplied by 3 minus 25. You will find this value. Approximation we get that. So that's what is the conclusion. The conclusion is that only 5% of the cases will demand during lead time exceed a variable inventory if the order of purchase is made when the stock reaches start. So it means we are having the stock which is which is there, when our stock reaches 30, only 5% of the case will be demand during the red time. But this will be an additional time according to the norm of 1. So where the level of the stock will be 30. So let's continue with gamma distribution. Gamma distribution of a random variable x is defined using a gamma function. So to define this type of variable meaning x, which follows gamma distribution, we have to define it using a gamma function. So which is a function which will help us to check whether the random variable x follows gamma distribution. So a gamma function for any beta greater than 0 will be given by the root of beta, which will be equal to integral of 0 to infinite x power beta minus 1 multiplied by Euler power minus x dx, like this. So we have to note that the root of 1 will be equal to 1, and the root of beta will be equal to factorial of beta minus 1 when beta is an integer. So this function will take different value, but will depend on different parameters. So we can say that it follows gamma distribution with parameter beta and the theta if its PDF is equal to this formula, like this part x, the requirement x must be greater than 0, otherwise it will be equal to 0. So here, for gamma distribution, the parameter beta is called as a shape parameter. We call it as a shape parameter, and theta will be called as scale parameter. So the expectation will be 1 out of theta, and the variance will be 1 out of beta theta power 2. So this the CDF, this function, the function will fx will be equal to this one. Fx is greater than 0, it will be equal to this formula by multiplying all of this. But this will be the result of 1 minus this function, and then if x is less than 0, it means that we get 0. So it means that the requirement x must be greater than 0. We can also have another beta distribution. For beta distribution, we are going to say that the variable x follows a beta distribution when we are having two parameters, b1 greater than beta 1 greater than 0 and beta 2 greater than 0, but it will be varied when we are having x which ranges between whose value between 0 and 1, and it will be equal to 0 when the value of x is out of the range of x. So we will have this value. So this value can be used while we are calculating the different value to check whether our x follows beta distribution or not. So here we can have different ranges where a will be equal to y will be equal to a plus b minus a. This is the range. The bigger range is b, the lowest range is a. So In such a way, if you are having the variable y, the expectation will be expectation of y will be equal to a plus b minus a multiplied by beta 1 out of beta 1 plus beta 2. This one. The variance also will be calculated like this. So this formula, in order to calculate to use beta distribution and gamma distribution, so it is almost as what we saw previously. You can check, you can use this formula in any problem solving. So if you know their value, what you have to have all values of this variable a, the variable of a, b, and the beta. So it is very easy to calculate. So next time we are going to see Poisson distribution. So in the next video we have to practice this, to read this, and then next I will post the explanation about the Poisson process. Thank you.